Today let's solve two geometry puzzle, where in the first puzzle over here, I have a circle and there is an inscribed triangle which is ABC, and then with the center O being the center of the circle, and then there are three squares which are placed inside of the inscribed triangle, and that is the yellow one, the blue one, and the red one. So we are given that the area of the yellow square is A square, and the area of the red square is B square, and our goal in this puzzle is to express the blue area, which is the area of the blue square, in terms of A and B. So to solve this puzzle, essentially we will be utilizing similarity of triangles. So I will first note that because the area of the squares are just the side length square, we know this length over here is A, so as this length, and then the length over here is B, and the length over here is also B. So now I'll label 6 more points, which this point over here I'll label it as D, and this is E, so as this is F, and then this is G, H, and I. And then we'll see that the triangle DEF is similar to the triangle IHG. And now let's quickly talk through our way why this is true. So we'll notice that the angle DEF is 90 degrees and the angle IHG is also 90 degrees. Well, this follows from the fact that both angles are supplementary to one of the angles in the squares. And then it is well known that because BC is the diameter of the circle, we know that the angle BAC is also 90 degrees. And then to show that the triangle DEF is similar to the triangle IHG, we just show that one of the angles in both triangles are essentially the same. And so if we can do that, then essentially both are similar triangles. So to show this, I will note that the angle DFE, which I'll put it as green, is the same as the angle ACB, because the side FE is parallel to the side CB. And similarly, we know that the angle GIH, which is the blue angle over here, is the same as the angle ABC, because the side HI is parallel to the side CB. And now it's not hard to see that the angle FDE is essentially the blue angle, which is the same as the angle GIH. And then this angle HGI is also the green angle, which is the same as the angle DFE, because all these three angles add up to 180 degrees. And they are also the same as the angles in the triangle ABC. So therefore, we have shown that these two triangles are similar. And now we can let the length that we want to find, which is the length of this blue square over here, to be equal to x. And then now we can see that the length DE is the same as x minus a, and similarly the length GH is the same as x minus b. And now by similarity of triangles, we know that x minus a over a is the same as b over x minus b. And then cross multiplying everything, we get that d is the same as x minus a times by x minus b is the same as a times by b. Expanding out everything, you get that x squared minus a plus b times by x plus ab is equal to ab. And then we can cancel off this ab both sides. So we're left with this following equation over here, and d is equal to 0 on the right hand side. And now we see that we can factorize out an x, and we're left with x minus a minus b is equal to 0. And because x is obviously positive in this case, we're left with the only solution is just x is equal to a plus b. So therefore, this tells us that the area of the blue square, which I'll write the area of the blue here, is the same thing as a plus b, the whole thing squared. And this is our answer over here. So now let's look at the second puzzle. So in the second geometry puzzle over here, I have a semicircle which has the diameter being a plus b, and there is the sum of the segment with the length a and the segment with the length b. And inside of the semicircle, I have kind of inscribed a circle with the radius r, such that it is tangent to the top part of the semicircle and also the diameter of the semicircle. And then based off this diagram over here, we're going to prove the fact that 1 over r is equal to 1 over a plus 1 over b. So to do this, essentially we'll construct some equation that relates R and A and B. So I'll first label the center of the semicircle, which in this case is O, and then I'll connect these 3 points over here. And maybe let's label this point of tangency as X and the center of the circle as Y. And then we can see that X, Y, and O are collinear because of the fact that they have the same tangency point, and that is the point X. And then now observe that XO in this case is the radius of the semicircle, which is A plus B over 2. And then we also have XY being the radius of the circle, and there is the length R. So this means that we have that YO in this case is equal to A plus B over 2 minus R. And then if we label this point, which is the point Z over here, we can see that YZO is a right angle triangle. And so essentially we want to find the length ZO in this case in order for us to apply the Pythagoras theorem. And it is not hard to see that ZO in this case is equal to the radius of the semicircle, which is A plus B over 2 minus of A, which is the length of the segment A. And this can be simplified as B minus A over 2. And then now we can essentially apply the Pythagoras theorem, which you get that B minus A over 2 the whole thing square plus R square is equal to A plus B over 2 minus R the whole thing square. Expanding off everything, you get that this is the same as 1 over 4 B square minus 2AB plus A square plus R square is equal to 1 over 4 A square plus 2AB plus B square minus R times by A plus B, which is the cross term, plus R square. And then now we can do a bit of simplification where we can see that there is a common term of R square both sides. And then now let's multiply the whole equation by 4 in order to get rid of the 1 over 4. We get that this is B square minus 2AB plus A square is equal to A square plus 2AB plus B square minus 4 times by R A plus B. Cancelling off the common terms, which is B square over here and also A square. And this negative 2AB can make this into a 4AB on the right hand side. And then we'll move this minus 4 times by R and A plus B to the left hand side, which will make this whole equation into 4R A plus B is equal to 4AB. And then we can divide out these 4 both sides. So essentially we're left with R is equal to AB over A plus B, which means that 1 over R is equal to A plus B over AB. And then this is the same as 1 over A plus 1 over B, which is the fact that we want to prove. And if you want to solve more interesting geometry puzzle, then be sure to watch this video over here.